Okay, so hi everyone. Thank you so much for joining and welcome you all in our course Data Analysis using R Programming. And today we are on the session first, and today we are going to cover about introduction to R programming. And in introduction to R programming part, initially we will cover about the research process, how a research process is being done, okay, and where we are and why we are going to learn about R programming. Okay, so let me tell you about agenda. So initially we will touch upon a research process, what exactly do into the research process, and after that we will start covering steps of analytical programming, and based on that we will touch upon the history of R and brief introduction about S programming languages, because R programming language is derived from the S programming language. And after that we will touch upon introduction to the open source softwares. Okay, so what exactly open source mean and how you can just download and utilize those software into your computer, okay, into your research part. After that we will touch upon the power of R, okay, and we will see that different types of R packages are available and what the packages is and why the packages is needed, and after that how we will install those packages into our system. After that we will touch upon the file extension part. Okay, so I'm seeing that Joseph hand raised, so please, yeah, Joseph, if you have any questions maybe you can tell, and after that we will start. Yes, Joseph. Okay, I guess your hand is raised. Okay, no problem. Okay, so yeah, so in the research process, firstly, what we are doing, we are just research process is basically a scientific steps just to perform or maybe find a new things from the existing things. Okay, so like for example, you are seeing that in everyone's country, government is having some policies. Okay, how this policy is being formed? So these policy are being formed based on the result of a research. Okay, so research is nothing but a scientific steps. Okay, scientific steps are combined together just to form something which is called as research. Okay, so what are the different processes of research is? So firstly, in the research process we need to define the questions, define the research question. Okay, okay, so I guess, okay, so maybe I don't know if my voice is coming to people or not, I don't know whether can anyone confirm.
Yeah, we can hear you clearly.
Okay, so maybe some internet issues are there. So please, yeah, maybe you can change your internet so that it will work. Okay, now defining the research process. So I was just defining the research problem. Okay, firstly, just try to identify what the research problem you wanted to solve it, and after that, you need to just review the concept and theories. Let's suppose if you wanted to perform a research into the policy development, then at least you need to have a basic understanding about how a policy is being formed. Okay, what are the different steps? So it means that you need to understand about the concept and related theories, that how the certain process need to be done. After that, you need to review previous research finding, what the research is already being done into the same area. You need to understand those things, learn those things, and draw some conclusion based on those particular articles. After that, once your research review concept and theories are done and you are done with the previous research finding part, okay, so we move for the formulation of hypothesis part. Okay, so under the hypothesis formulation of hypothesis part, whatever the things we discover, uh, we define the problem. Okay, so under the definition part, what the things you wanted to solve, you are just defining the hypothesis around that. Okay, hypothesis means like whether these things will be good or not. Okay, whether this will be benefited to the society or not. Okay, so this kind of things you are just developing under the hypothesis part. Okay, so once the hypothesis will be formed, now you will go for the designing of a research problem. Okay, so designing of a research study is including the sample design as well. So like for example, if you wanted to perform a research design, you need to understand that from where you will collect the sample, how much sample you will collect. Okay, so these are the few basic details you need to keep into a document, and what type of study you will perform, whether you are performing a research, observational research, or maybe experimental research, or maybe um, you are taking the data from the secondary data sources, tertiary data sources. Okay, so there are different ways are there, so you explain all those ways into the design research part, and you will give a very broad or very detailed document. Okay, so in this every steps everything will be clearly explained about the research part. Okay, so once your design of research is completed, you completed your design of research part, your design is ready. Okay, you need to deploy it. Okay, so once your design is ready, then you will go for the data collection part. Okay, so you will collect the data. It means that whatever the design you had made, you will start executing that particular design, and you will start collecting the data from the real population. Okay, now once your data is being captured, okay, so once you are having your data into maybe into the some pages, or maybe some different softwares like maybe Microsoft Excel, or maybe some other spreadsheet, maybe Google spreadsheet, or somewhere you are having this data. Okay, or maybe in your pen and paper based theory, you are collecting the data into pen and paper based, so data will be there into the papers. Okay, so once your data is being collected, now we move ahead for a different part which is called as data analysis part. Okay, so data analysis part is the gist of this particular research process is. Okay, so in the data analysis part, what we are doing, we are just testing this hypothesis, what the hypothesis we have formed. So we are testing that particular hypothesis under this particular analysis part. Okay, now once your analysis is being done, okay, so whatever the statistical estimate you find out, okay, you will move ahead with this particular estimates, okay, these results, and you will interpret it. Okay, so like for example, if I'm taking a very real example of a water and hygiene. Okay, so you will set up a research problem that in a rural areas the hygiene issue is there. Okay, in comparison to city areas. Okay, or you can say in the urban areas. So what the research problem you are having, you wanted to compare that the hygienic issues are there in villages in compared to urban areas. Okay, maybe this is a research problem you had beside. Okay, now you will start reviewing the research concept and theories. Okay, in the research concept and theories, what you will cover, like you will cover the material, that how this research will be performed. Okay, what type of data you need to capture. Okay, and after that you will move ahead for the review of previous research funding. So let's suppose someone else have already been done a similar kind of research studies. Okay, maybe your friend, or maybe your college mate, or maybe some your office mate, someone already being done this type of studies. So you will download their literature, and you will see that what type of study design they have used. Okay, what the outcome of their particular research study is, whether their research study is covering a specific area or your area. Okay, so you will find out the things from this particular article. Once you review all the article, then you will find a space. Okay, you will find a space that what the research you are thinking, this research is not being done, okay, at all, and this is the gap you wanted to fill it by using your research. Then you will go for formulation of hypothesis. Okay, so you will form the hypothesis like the city area is having more hygienic issue than urban area. You set up this hypothesis. Now you will collect the data. You will design the research. Okay, in the designing of research part, like you will design it how the sample will be collected. Okay, how many sample will be collected, how the data will be collected, either in the system directly, laptop, or maybe mobile, or maybe some maybe internet based devices. Okay, or you will use a questionnaire. If you are using a questionnaire, then you will develop a questionnaire. Okay, you will find out the questions, you will place all those questions into a questionnaire. Okay, and how many sample you will collect. So all those details you will include into a concise document which is called as research document. Okay, so once this document is being finalized, you will move ahead for the data collection part. You send your surveyor, or maybe your friend, or maybe your employees. Okay, give them the questionnaire, give them the question that go and collect the data from rural areas, collect the data from urban areas. So once the data will be captured, so this data will be stored at some places. Okay, maybe in an Excel sheet, maybe in a Google spreadsheet. Okay, or maybe some other databases. So once your data is being collected, now you will move ahead for the data analysis part. So data analysis part itself having multiple steps. Okay, we will cover those parts in our later slides. Okay, that what are the different steps of a data analysis, because data analysis is a very huge topic at altogether. Okay, so under the data analysis part, what we are going to do, we are just going to generate some information from the collected data, okay, what you had collected in the step number 5. Okay, so you will generate some estimates from there, you will get some kind of information from the data. Okay, so like for example, uh, men's are more kind of the females are more aware about the hygienic things rather than the male. Okay, so this information you are collecting from you are collecting the data of different types. Okay, now during the analysis part you just analyze your data in such a way that you can able to distinguish and between male and female. Okay, and you are driving the information into by using this particular variable like male and female as a subgroup categories. Okay, and once your data analysis will be done, you will go for testing of hypothesis part, you will test it. Okay, and once your hypothesis test data analysis part is completed, you will have some estimates with you. Okay, then you will go for the interpretation part. Okay, so like for example you will have some 95% confidence interval, maybe you are having mean, you are having median, you are having mode. Okay, maybe some other type of statistical estimates are there, maybe point estimate, maybe some Bayesian theories based estimates are there. Okay, and similarly maybe you apply some statistical machine learning model, so you will get definitely some output. Okay, so you need to go for interpretation part. Okay, now once your analysis will be done, then with that particular estimates you will go for the interpretation part. So you will interpret the result finding what you are getting it from the data analysis part. Okay, so once the interpretation will be done, you will go for the publication part. Okay, now you in the last step you will create a research paper and a specific layout. Okay, based on the which journal you are targeting. Okay, where you wanted to publish your research. Following that particular journal layout, you will create a document, okay, which is called as a research paper, and you will apply for the publication. And if in the peer review process or publication process everything is perfectly fine and your research will be validated, then it will automatically published by the publication agencies and it will be available for the public general public to utilize it. Okay, now our research is done. Okay, with these steps our research problem will be completely solved. Okay, a paper is coming to the general public to utilize it or maybe use and draw some meaningful conclusion for a particular policies. Okay, that maybe government can utilize this particular research paper for developing some strict guideline for the policies. Okay, or maybe some private companies they wanted to set up some business around that, they can utilize this particular research paper and they will establish their businesses into that type of areas. Okay, so this is all about the research process. Okay, now coming to the steps of analytical programming. Okay, so like what we have seen in our previous part, data analysis part. Okay, so in the data analysis part, okay, we do the data analysis, then how we will do the analysis? Okay, definitely we will use the analytical programming. Okay, so what are the different steps of analytical programming is? Okay, so the first and the foremost step is import or create the data. Okay, so as I told, in a research process everything is dependent on each others. Okay, so once your data is being captured, okay, then you will import that data into the analytical programming. Okay, so if you maybe import your data from different data sources or maybe you can create your own data by typing manually into the systems. Okay, so in that way you will create the data. Okay, and data comes from file, data maybe comes from databases, data maybe come from different web APIs. Okay, so these are the way how you can take your data into your system. Okay, now once your data is come into your system, okay, or you can say is into your analytical programming part. Okay, so you will move ahead for tidying process. Basically tidying process is called as data preparation process. This is the part of a data preparation. Okay, so under the tidying process what we are doing, so tidying is basically just prepare data in such a way that we can perform some algorithm into this particular data. Okay, so tidying is generally having five golden rule. Okay, we need to follow these five golden rule. Okay, these are basically a semantics of a particular data type, data structure. Okay, so what are those? So like for example, whatever the data you are having, so every variable is stored in its own column. Okay, so it means that there will be a different columns are there. If you know about Excel software, then definitely you may know that Excel is having one column, okay, two column, three column, four column. Each column is having their own variable, okay, means each column will store a specific type of values, okay, which belongs to a particular variable, okay. So every variable is stored in its own column, and the second rule is that every observation is stored in its own row, okay. So like for example, if I am collecting a data for a person A, okay, person 1, okay, so all the data, whatever the data we are asking for a particular research study, okay, so all the data will be stored in a one row, okay, so that one row will called as a one person data, okay, and one variable will be called as a one column data, right. So each value of a variable is stored in a cell of the table, okay. So definitely there will be a two-way tables will be there, where we will have multiple columns, you have multiple rows, okay. So each cell, okay, will represent a single value. So like for example, if you are asking their address, okay, and he is or she is providing their address with their house number, with their city name, with their area code, with their country code, okay. So he is or she is providing multiple details. So if you are storing those details in a different cells, okay, then it means that you are not following the tidying principle. What it means, you need to store all those things in a one cell, okay. This one cell will be called as a one data value, okay. The fourth step is that value should not contain units. Rather, units should be specified in the supporting document for the datasets, which is called as codebook. Okay. So, like for example, if you are capturing their height, okay, their weight, and you are capturing the height in inches or meters, okay, do not put your data with the corresponding units. Okay, just to put the data and give develop a codebook along with the data. In the codebook you mention that this particular variable is collecting the data about height, and height is being captured into the inches or meters, okay. In which way you are capturing, in which measurement you are using, you will mention these things into this particular document, okay. And in the fifth and the last step is that there should be no extraneous information like footnote, tables, titles, etc, okay. So whenever you are just have develop or importing your data should not have any footnote information, any table title into there, okay. So because this is important, why this thing should not be there, because when you read your data into your analytical programming, this extra information can mislead the data sets, okay. So for that reason this information should not be there. We will create a code book, or you can say a metadata file. Over there we will explain all those things in a more elaborative way, that for which type of data we are capturing, what the data is, what the variable name, okay, what the variable is signifies, how the measurement is being done, okay, what are the different units we are having, okay. If you are wanted to give any table number, table name, or you wanted to include a footnote, okay, you can mention all those details into the metadata file, or you can say the code book file, okay. So these are the steps, these are the five golden rules we are having for tidying process, okay. So once the tidying process is done with the data, now you will move ahead for the data transformation, okay. So what it means by data transformation? So data transformation means maybe whatever the data you are having, based on that data you will create a new variable, okay. So let me take an example. Suppose you are having height into the data set, you are having weight in the data set, and based on the height and weight you wanted to create a BMI, body mass index, okay. So there is a one formula we are having. Using that formula we will create a new variable BMI by using those two variables. Other things, maybe you can create a grouping, like for example, maybe you are collecting the data and from the male female, okay. So you are capturing the data and you are grouping the data into two categories. One is for male, another is for female, maybe third category is also there, okay. In that way you will create a group, okay. So group creation is also a new variable creation part. After that you will transpose. Sometimes we transpose the data, okay. So like for example, I wanted to see the same variable name, or maybe separate the data based on the male and female altogether different, okay. So what I will do, whatever the data I am having, I will just transpose the data, so that maybe I can see each data at two times. One is for male, one is for females, okay. One variable is showing for female, one variable is showing for the information of males, okay. So this is called as transposing. Okay. Now, good thing. So what we have covered under the tidying process and what we have covered into the data transformation process. Okay, so those two things combined together, and in the latest era, in data science era, these two things together called as data wrangling. Okay, so now what it means by data wrangling? So data wrangling is nothing but a processing of data. Okay, whatever the data you have captured into the research process, okay, you are just transforming those data in such a way that you can perform some analysis into that data. Okay, so after this particular steps means what I mean to say, after the data wrangling process, you are ready for doing the analysis. Okay, now when you are ready for the analysis, then the first step of analysis is that go for the visualization. Okay, you will do the visualization activities. Okay, now what you will do under the visualization activities? Okay, so visualization is very much important. Okay, why it is important? Okay, so firstly let me tell you about why visualization is important, and after that what are the different things we need to follow for a visualization. So visualization is important because we know a very famous quote is there: a picture is worth thousand words. Okay, so a picture, if you are just created an image, okay, created an image, this image will definitely elaborate more than you will result it into that tabular format. Okay, so you can just take a bird eye view and you will get the information about this particular data if data is in the pictorial form. Okay, that is why data visualization is important. Okay, now it itself have some different rules. Okay, so there are few golden rules are there for the data visualization activities as well. Okay, so like for example, you have collected the data. So firstly, you need to understand, or you can say determine the best visual. Okay, so like what the visual you wanted to present. Sometimes you may present the scatter chart. Sometimes maybe you are presenting the bar chart. Maybe you present the histogram. Maybe you will present the pie chart. Maybe you present some waterfall chart, violin plot. Okay, what so many plots are there? Okay, according to the your research study, according to the your data. Okay, you will choose the visualization. Okay, that is why the first step is called as determine the best visual. Okay, so after that, keep things simple. Simplicity is general rule you need to follow in everywhere. Okay, so same thing you will follow into the data visualization as well. You need to keep the things as simple as it can. Okay, use color coding very wisely. Okay, like for example, if you see this particular slide, okay, so this slide in such a way that this is eye pleasing. Okay, this is definitely not kind of creating pressure into your mind as well as into your eyes. This is little bit eye pleasing. Okay, so you need to select the code color code in such a way that this should be eye pleasing. Okay, not in such a way that it is just kind of creating pain into the eyes. Okay, so color coding should be very wise. Okay, and then the fourth step is that highlight the most important information. So for which you are just creating a data visualization, this information should be conveyed into this particular visualization. Let's suppose if you wanted to see the trend between two variables. Okay, like for example, maybe trend between height or maybe age and salary. Okay, so you wanted to establish a trend, like you know that if age is increasing, experience is increasing. If person's experience is increasing, their salary will increase. Okay, so it means that there is a positive trend you will find out. Okay, so in this visualization, you need to identify the trend, what type of trend you are seeing into this particular visualization. So this is the most important information with what you wanted to convey by using this particular visualization part. Okay, so this information should be there. Now keep less busy. Don't put so many information into this particular visualization, because if you are keeping so much information into this particular visualization, most of the people will not able to distinguish that what information is telling what. Okay, so for that reason you need to just create a visualization which is very less busy. Okay, like for example, if you wanted to show a simple linear trend, okay, so just to put two variables, nothing else. Okay, two variables and their trend, whatever the trend it is coming, whether this is an increasing trend, decreasing trend, whatever it is coming, just present as it is what you are seeing, along with the title, along with the footnote, x-axis name, y-axis name, label. This information should be added into this particular visualization. Apart from that, no need to present so many information like in a single chart. Make histogram, make maybe density chart, maybe p values, maybe some line chart. Okay, don't keep all those things together in a one bucket. Okay, so this is the general principle you need to follow for the data visualization activities. Okay, so once your data visualization is completed, now you need to move ahead for the data analysis part, because you are having a very ground level information about the data by using the data visualization technique. Okay, so you will move ahead for the data analysis part. Okay, maybe let me give a little note. Okay, so these are the general steps I am showing over here. Okay, so these things I will cover in a much more detail in our coming sessions. So these are the currently I am just telling you about what are the different steps are there just for a particular research process. Okay, and what are the steps are there into the analytical programming. I'm just covering in a very broad way, and after that we will cover those details in a much more those details in a very elaborative way. Okay, maybe in later sessions. Okay, so under the data analysis part, now when you able to perform your data visualization, you are having a very solid understanding about your data. Now you will move ahead for the data analysis part. Okay, so what are the things into the data analysis part? So majorly there are three things we are doing into the data analysis part. So the first is that just to create a descriptive statistics. Okay, so descriptive statistics means what? Just to present descriptive summary about data. Okay, what it means by descriptive summary? So like for example, you are just collected the data, and based on that data you wanted to assess what are the mean of this particular data. Like for example, what are the mean age of the men's, okay, in that particular village. Okay, what are the mean age of females in that particular village. Okay, so this whatever the descriptive statistics we are calculating, like mean, like median, mode, standard deviation, okay, and variation, and quartiles, quantiles. Okay, so those details are called as summary statistics. Okay, so these are comes under the domain of descriptive statistics. Okay, once your descriptive statistics are done, you are just tabulated all those data, and you are able to find out the descriptive statistics. So once you are comfortable with descriptive statistics, now you will move ahead for the inference part. Okay, statistical inference part. Now statistical inference did what? Statistical inference will just go for estimation and testing part. Okay, so estimation and testing part is there. So in the estimation part you will just estimate the things. Okay, so like for example, you will estimate a particular statistical estimate. Like for example, maybe you wanted to assess the central mean. Okay, maybe population level mean you wanted to assess. Okay, so you will estimate it, and after that you will test it whether these assumptions as per your data or not. Okay, so estimation and testing process we will do under the statistical inference part. After that, in the third steps, once your hypothesis will be tested or you done with the estimation part, you will move ahead for the statistical modeling part. Right, sometimes means these are the very interchangeable steps are there. Some research may include descriptive summary only. Okay, so like most of the social science research, maybe most of the epidemiological research, biological research, they do not have that much more detailed about modeling and inference part. They may have descriptive summary, they may have statistical inference part. Okay, if your research study is requiring the modeling part, like for example, if you wanted to perform a machine learning technique over there. Okay, so these details we will come under the modeling part. Okay, so what we are doing in under the modeling part, we are fitting the relevant model for the prediction. So like for example, logistic regression we will fit just to distinguish between two variables. Okay, just to understand whether this particular response will be there or not. So like for example, if you wanted to fit a model just to predict that whether the newborn baby will be baby girl or baby boy. Okay, so this kind of things are there. Okay, this is definitely a legal thing. Okay, but this is just a statistical model. Okay, so we can try to fit it, or maybe in a early morning tomorrow when the share market will be open, the price will be high or not. Okay, or maybe some particular politician will win the election or not. Okay, so these are the things we can predict by setting up the statistical model. Okay, so these things we used to do into the modeling activities part. Okay, so once your modeling activity is being done, it means that you are almost done with the research part. Okay, a data analysis part. So now you will go for the presentation part. Okay, so presentation part will have again whatever the things you did into the data analysis part, you will present those things. Okay, how you will present? Okay, so maybe you can present your data into the files. Okay, like for example, you are working in some government organizations, and your seniors is asking for the results. Okay, you will provide them the result, what the result you are finding into the data analysis part and data visualization part. You will combine together into a file, and you will provide this file to your seniors, or maybe the respective stakeholders with for whom you are doing the research. Okay, or maybe you can provide the figures. Okay, what the things you did into the data visualization, you will directly provide those details to them. Okay, also maybe you can create a dashboards. Okay, so like in our means after later means this course, we have one session which is called as shiny. Okay, so you will create a dashboard. Okay, this dashboard will have much more information, whatever the statistical estimates you are finding. You can integrate those research estimates into this particular dashboard, and interactively you can utilize this dashboard for general purpose. Maybe you can integrate your research finding into a device. Okay, so like for example, someone is working into the mine. Okay, maybe in a coal mine or maybe in the gold mines. Okay, someone is working, and there may be a methane gas leaked. Okay, so maybe hazard happen. Okay, people will die. Okay, so what you can do, you will do the data analysis. Okay, and based on the data analysis, you set up a model that will distinguish, or maybe get a knowledge about methane emission. Okay, so earlier, as soon as possible, you get the information, you will just put alarm, and this alarm will start blowing. Okay, then people will aware that this particular mine is not safe now, methane emission is started, so we need to get out from this particular mine. Okay, so in that way you can integrate your research findings into a device, maybe in a landslide prone area. Okay, so you set up a model which actually predicting the landslide. Okay, landslide. So once your analysis is being done, you will integrate your research into the sensors. Okay, those sensors will collect the data. Okay, they will analyze it. Okay, and based on the analysis, they will give us the message that this area is not safe. Okay, this area is now very landslide prone area. Please move ahead from this area, otherwise hazard will happen. Okay, people will get this message, and they will leave instantly to this area, so that they will safe. Okay, evacuate that particular place. Okay, in that way you can do the presentation. Okay, so once your presentation is done, for sure you will go for the creation of a research paper, and after creating the research paper you will publish the research. Okay, so these are the general steps of a analytical programming. Okay, so around all those steps, okay, what we have seen, so around all these steps, what will be used? Okay, what we are using? Okay, so around all those things, what we are using? So we are using programming. Okay, we are using programming. Okay, so from importing the data, after that we tidy the data, we just transform the data in such a way that we can have a data analysis ready. After that we do the data visualization part, and after that we go for the statistical analysis part, where we have created the descriptive statistics, we do the statistical inference, and we set up the statistical model. Okay, and start predicting it. Once you explore those domain, you will communicate your finding to the society, so that anyone can get the benefit from that particular research. Okay, so my focus is on the programming part over here. Okay, because throughout the data analysis part, you saw that in each and every step, from importing of the data to publishing your result, okay, in every step you are using the programming. Okay, that is why we are here connected together, so just to explore the programming part. Okay, so now, since as discussed, firstly we are planning to cover the R programming, because R is free source available program. Okay, and this is a very easy software. Okay, you can learn this software very easily. Okay, in a very less time, and you can perform your daily data analysis related activities. Okay, into this particular software. Okay, so let's understand about R programming. What is R programming? But before moving to the R programming, I wanted to collect if anyone have any questions. So maybe, yeah, anyone have any question we can discuss. Hi Jose. Hi George.
Yeah, thank you very much. I would like you to go back to the modeling aspect of the data for me. Just a few
Yeah, yeah.
uh,
Mm-hmm.
explanation will do. Thank you very much.
Okay. Yeah, so like
Mhm.
when you do the data analysis part, Okay, so statistical modeling means you are just setting up the models. Okay, so what the model means? So like for example, you are having presidential elections, you are having prime minister election. Okay, so you are getting the result, but prior to the results, some opinion polls are there. Okay, based on the opinion polls, people are fitting the model, and based on the models, they are concluding that the particular person maybe win the particular election. Okay, similarly, maybe I wanted to fit a model for predicting the gold price. Okay, so based on the different parameters like maybe the repo rate, okay, maybe the dollar price, maybe the inflation rate, maybe the deflation rate. Okay, so whatever the different parameters are there, we will establish a relationship between gold price and those variables, so that this relationship is called as statistical model, and based on this model we can predict the new price. Okay, new price, maybe new leader. Okay, so in that way we are doing the statistical modeling. Okay.
Okay, thank you very much.
Yeah, perfect. Now moving towards the R programming. So R is a language and environment for statistical computing and graphics. Okay,
I
so
have a question.
yeah, please go ahead.
Uh-huh. Good evening. Please, I want to understand. Can you do the modeling without? Is there a way you can do modeling without going through the descriptive statistics and then the inferential statistics? Is there a way you can, or are you supposed to do the inferential statistics before the results that you get? That is where you can use to do your models. I
Okay.
just want to know. Thank
Yeah,
you.
yeah, yeah.
And again, are we going to get our slides? The recordings and then everything. I'm going to get it.
Yeah, yeah, yeah. So everything will be available, okay, readily available into different links. I will place all those details into the WhatsApp group, okay, after this session, okay. So you can access from there. Now coming to the your questions, like can we do the statistical modeling before? Okay, maybe statistical inference before. Okay, so it depends. Okay, like what type of research you are performing, but ideal way is that firstly go for the data visualization part, and in the data visualization part you will have a basic understanding about your data. So if you able to understand your data, okay, then you are having a good hold into the data. Okay, so once you are having good hold into the data, then you need to go for the data analysis part. Okay, so in the data analysis part, firstly understand about what the descriptive statistics for this particular data is. Until unless you are not getting what exactly the mean is, okay, what the missing data is, okay, how many number are missed, how many number are extreme values. Okay, if you don't know about those details, if you fit directly the model, this model may misleads your results. Okay, so firstly you need to check all these discrepancies into your data by using the descriptive statistic part. Also develop a very basic understanding about your data, okay, using the descriptive statistics. After that move ahead for the estimation part. Okay, estimation and statistical modeling, those two things you can utilize as per your research. If your if your data analysis is only just for testing of hypothesis, okay, so you need to only do that statistical inference, no need to move ahead for the modeling part. Okay, so like for example, suppose if you are doing a biological research, okay, maybe you are just performing a trial between two treatments. Okay, so if you wanted to establish the result that treatment 1 is good, treatment 2 is not good. Okay, so at that time what you are doing, you are just testing this particular hypothesis whether this treatment A or treatment B is good or not. Okay, so you are just testing only, that is why you will only follow the statistical inference part. Now if you suppose you are doing some prediction activities, okay, so like for example you wanted to go for prediction of a gold price, okay, or maybe you wanted to predict the GDP values, okay, or maybe you wanted to predict the inflation rate. Okay, so if you wanted to predict those things, at that time you need to establish the relationship between those dependent variable which are important. So like for example, if you wanted to predict the rainfall, okay, so rainfall is depend on multiple factors. Okay, maybe air pressure is there, okay, temperature is there, okay, and some other variables are also there, humidity is there. Okay, so those variables are required just to predict the rainfall. Okay, so you will establish a relationship between those variables, and with this particular established relationship you can predict whether there will be a rain or not. Okay, so this is called as statistical modeling part, right? So these three things are interdependent as per your research requirement. Okay, you need to choose which step you need to perform. Okay, but this is the way ideally you need to perform a data analysis activities. I hope I am able to answer your question, Richard. Okay, let's move to the R programming part. So R is a language and environment. Okay, and
Yes, please. Yes, please. Thank
okay,
you.
yeah, thank you. Okay, and it's an environment for statistical computing and graphics. So what it means by language and what it means by environment. Okay, so language is just a medium. Okay, how you can write something into the computer, that is called as language. And environment is basically called as a system. Okay, over there you will perform something. So like for example in R is providing you just to code the things. Along with that, different packages are there, different modules are there. You can integrate those modules and you will get the statistical result, or you can say data analysis result from your data. Okay, that is why this is called as programming languages along with the environment. R is a open source programming language and freely available into the market. Okay, so I'll touch upon the open source programming language maybe in the later of the slides. Okay, so R programming is widely used by the statistician, data analyst, researchers, academicians, it etc. Okay, anyone can use R programming. This is not limited to those roles. Okay, anyone who is doing the data analysis related activities, who can utilize this particular programming. Okay, now what are the features we are having? So data manipulation and data analysis. With using by using R, we can do data manipulation and data analysis activities. We will use some statistical techniques into this particular programming. We can do the data visualization. Okay, wide variety of package ecosystems are there. Okay, and we can whatever the result we will do using this particular programming, this is reproducible research. Okay, in the research, reproducibility is the core concept, right? So whenever you are doing the result using the R programming, always this will be reproducible. It is not necessarily that if you develop a model and the model result today this model is giving good result and tomorrow this model is not giving any result. Okay, so this will fail the concept of reproducibility. Okay, but R based analysis will provide you such kind of functionalities. Okay, now what are the different types of software? Okay, so there is basically two types of software we are having. First is called as proprietary software, another is called is open source software. So proprietary software basically are software code which is maintained by only a person or a team or a corporation. Okay, so like for example if you see Windows or maybe in the Microsoft. Okay, so IBM softwares, SPSS, Stata, so those are basically a proprietary softwares. Okay, just telling you about different types of softwares. Okay, so we do have two majorly types of softwares are there. So first is called as proprietary software, second is called as open source software. So proprietary software basically are the software which is managed by a corporation. Okay, so like we are having many softwares in our systems like SPSS is there, Stata is there, Microsoft Excel is there. Those softwares is basically called as proprietary softwares. Okay, so these are basically legal copies. Okay, if we purchase this software, okay, then only I will get the license and I can utilize those things. Okay, so that we can utilize this particular software for our purpose. Okay, and into this software we cannot alter anything into this software. Okay, if you wanted to change something, okay, we cannot able to change into this particular software. We can only use this particular software. Okay, like for example MS Office is there, Windows is there, IBM SPSS, SAS, eViews. So those are basically a software proprietary software. Okay, so now what is open source software? So open source software is basically a developer code is openly available. Okay, so like for example R is a open source software. This is freely available. Its code is freely available. Anyone can see it. Okay, anyone can alter it. Anyone can rearrange it. Okay, so user is not legally bound into this. Okay, so in this particular software user is not bind. Okay, user can't change anything into this. User can perform their own analysis activities over here. Okay, maybe any other activities can perform. Okay, so he is not legally bound at all. Okay, no need to sign the end user license agreement because this is a free source software. No one is restricted and to not, no one. Okay, so that is why end user license agreement is not required for this particular type of software. For example, we are having LibreOffice, we are having RPython. Okay, so these are the free source available. Okay, which is available online. You can download it and you can start utilizing this particular software. Okay, someone join. Okay, now coming to why free R. Okay, why free R? Okay, this is very good question. Definitely exciting too. Okay, a very famous quote is by Benjamin Franklin. As we enjoy great advantages from the invention of others, we should be glad of an opportunity to serve others by any invention of ours. Okay, so like for example, if you are just sown a tree, someone will take the fruit from them. Okay, then if you took the food from someone else's tree, you need to again just plant a tree. Okay, so that anyone can also benefit from your tree. Okay, so this is the general meaning of open source thing, or you can say the free things, that you definitely enjoyed the things. Okay, you definitely enjoyed the things which is being developed by someone else. So like for example, you someone developed the R software. Now you are going to use this R software for your data analysis activities. So whatever the research process you will research problem you will solve, provide the research result to the general community so that anyone can utilize this particular research. Okay, and get benefited. So if you are just taking the fruit of someone else's research, then do some research in such a way that your fruit will be enjoyed by others. Okay, so this is a famous quote from the Benjamin Franklin. Okay, most of the people will definitely know him. Okay, if not know, please go and just search him and understand about this particular person. He is a very great scientist. Okay, now now the next step is that um, on a similar line, okay, our software is free software which comes under the GNU license. Basically, GNU license is basically open source software, free software. Okay, GNU is providing you the operating system which is freely available. Okay, you can perform any software development activities into this particular operating system. Okay, so since R is actually based on this particular operating system, that is why R is freely available. Okay, now free software puts its user under control of their own computing. Okay, so like for example, since it is a freely available, so whatever the research you wanted to perform, you are not bound with anyone, you are free to do so. Okay, everything is under your control. Okay, so free things always be helpful for anyone. Okay, if you are able to afford it, okay, then only you can purchase. But if you are not able to afford, then these free softwares, these free things can help you out to just perform the analysis. Okay, so that your research can be benefited to others as well. Okay, so non-free softwares are those softwares which actually puts you are not the controller part. Okay, someone else like the software developer will control your ideas. Okay, so like for example in the Microsoft Excel, suppose if you are utilizing a Microsoft Excel, then whatever the functionalities are provided by the Microsoft, okay, only those functionalities are there into this software. Okay, you cannot customize anything into this software. Okay, your result is not at all your control. Everything is controlled under the developer of this particular Microsoft Excel. Okay, so that is the benefit, and that is why we are utilizing this R as a free software. Okay, now let's understand about its brief history of R. Okay, so initially in 90s we are having only one software which is called as S. Okay, so S language was used for just doing the statistical or maybe mathematical research. Okay, so there's a two scientists, Robert Gentleman and Ross Ihaka from Auckland University. In 1990 they have implemented this S language. Okay, from the inspiration of S language they have implemented their concepts into one other programming language which is called as R programming languages. Okay, and they had established this particular programming language as an open source in 1995 and open it for the general public can utilize it. And since then, okay, in 1997 our project was managed by the core group. Okay, there is a one group is there. Okay, there is a few persons are there, they are managing this particular software. Okay, they are, this particular organization is a free of cost organization, no one is charging anything. They are freely providing the services to this particular, dedicated services to this particular project. Okay, they are managing the things, they are getting the library updated just to remove all the misuse things. Okay, maybe establishing the security features. Okay, those things are done by those particular people. Okay, this is basically our community. Okay, so John McKenzie and Chambers is John McKenzie sorry McKinley Chambers is the creator of S language. Okay, so as R is taken from the S language, and very much R language is having general syntaxes of S language. Okay, very similarity is between S language and R language, but the thing is that S is not freely available, this is a commercial software, and R is a free source software which is available for a general public to utilize it. Okay, and after that this particular person like John Chambers, okay, so who creates the S language, and now he is the core member of R development group. Okay, so he is the core member of R development group. Now in 90s, as I told, there's only two three languages are there, among them schemes and SAS S are there. Okay, those are the most important software we will utilizing at that time. Okay, but those are basically a commercialized software, so research were restricted to those softwares only. Okay, since those softwares are not freely available, so it was very problematic for the new researchers to just establish their career into the research domain. Okay, so Robert Gentleman and Ross Yaka, they have thought that maybe we can just take some help from the S language, and we can develop a new programming language which is freely available for the community. Okay, so this is basically exactly same to the S language, or you can say very minimal syntax difference are there between R and S language. The only difference is that S is not free of cost, but R is a free of cost available. What the changes they have made? Okay, they have made the changes on the compiler level. Okay, or you can say interpreter level. So basically, compiler and interpreter, those two are the most important part of any programming language. Okay, so compiler means when you are writing all your code together and then submit your code to the compiler, and compiler will compile all those code, and it will start processing the result. Okay, but interpreter is different thing. Interpreter is processing the things step by step. Like for example, you will write a single line of code, you will able to run it. Okay, you will get the result. After that, go for another line, you will run it and you will get the result. Okay, then again move for the third line. Okay, so R is basically a interpreter based language, but S was based on the compiler based language. For developing a good hold, maybe you can Google it. Okay, and try to learn about the difference between compiler and interpreter. So along with the compiler change, okay, they have changed two major things into this particular software. Okay, what are the two things? The first is memory management. Okay, so there is a very slight difference between S memory management and R memory management. Okay, so S is allocating the fixed amount of memory to the startup. Okay, so when the program is starting, okay, a fixed memory is being allocated to this particular software, and this is utilizing throughout the data analysis activities. But R is basically adapting a dynamic allocation. Okay, how much memory is required? R is only adapting or getting this particular memory and utilizing this memory for data analysis activities. Okay, and this is working based on the concept of fly garbage collector. Okay, so fly garbage means what? Garbage is basically just a waste thing. If something is not required, just to delete it. Okay, so R is actually following this particular concept of fly garbage collector, and this will help out to just remove the heap growth. Okay, so that if the memory is not that much busy, so your performance will be increased. Okay, so garbage collector is what? Garbage collector actually manages the allocation and release of memory in real time. Okay, so now another thing, another difference between S and R is, the first difference is memory, the second difference is scoping. Okay, so scoping will be of two types. R actually follows the lexical scoping, and S is actually following the dynamic scoping. So lexical scoping and dynamic scoping part we will cover in our actual programming session, when we will have a live programming. Okay, over there I will tell you about the scoping principle, what exactly scoping means. Okay, and what is the difference between lexical scoping and dynamic scoping. With these two major differences, R is a very good language than the S language. Okay, and this is accepted by the huge huge community. Okay, now coming to the R management. So as I told, R is a free source programming language. Okay, it is freely available to the society. Okay, so this is completely decentralized and this is managed by the non-profit company. Okay, so R is not a company. Okay, there is a no specific company are there which actually earning the profit. Okay, since this is only managed by a couple of peoples and they have formed a non-profit company. Okay, anyone can develop their own packages. So like for example, many of you are doing a specific type of researches. Okay, and you find out that some result you created and some formula you have developed, and this formula is not available into the software. You can create a package, you can upload those package for general public use. Okay, so anyone can utilize it, anyone can contribute it, okay, contribute into this particular system. Okay, so that is why this is comprehensively growth. Okay, so much comprehensive growth you can see into this particular software. Okay, so all those things are being stored into a network which is called as comprehensive R archive network. Okay, so all comprehensive results, okay, all comprehensive packages are being uploaded into a archival network which is called as CRAN network. Okay, CRAN means comprehensive R archive network. So whatever the details are there, any document, any command, any package, okay, any functions, any specific data set, all those things are being uploaded into this particular place. Okay, now when you develop any statistical analysis package, okay, analysis package means a specific type of functions which is being utilized by a specific area. So like for example, if you are working your research into the drought area, okay, or you are working in a maybe landslide based researches, okay, or maybe some natural hazard prediction part, or maybe the mining analysis related activities. Okay, so you will develop some packages around that. Okay, maybe you find out some different method, new method, you generate some new method and you wanted to provide this method to the R community. You will develop a package, and when another person will come, okay, like for example, if you develop something and I am also doing the similar kind of research, I will find your research. Okay, I will utilize your function. Okay, I will give you the credit for sure. Okay, but I will utilize your package and I will use this package for my purpose. Okay, so if I will use it, it means that I am verifying this result what you had developed. Okay, so that is why this is called as this is freely available. You can easily download it, easily work it, and easily enhance it. Okay, so your work what you have done, community is verifying this because this is freely, anyone can download it and anyone can verify it. Okay, now coming to the power of R, what the power it is having. Okay, so due to open source programming, okay, open source system, it has a large community of users. Okay, so since community is high, so contributor is also so many. Okay, so large community, like we, I am from India, you are from Nigeria, someone is from Kenya, someone is from some other countries are there. Okay, maybe you are from Ghana. Okay, so we are contributing together. Okay, it's a huge community. Okay, and R is having a huge community, people are there, they are doing the analysis, they are contributing into this particular platform. Okay, so that is the power of R. Okay, that is actually contributing towards the power of R. Now, and effective data handling and storage facilities. Okay, so when you do the actual programming, then you will see that it is handling the data very effectively, and it provides you the data storage facility as well. Okay, so many operators are available for calculating based on the arrays or maybe matrices or maybe data frames. Okay, so many operators are available. Large and coherent integrated collection of intermediate tools of data analysis. Okay, so many graphical tools are available, very nice plots you can generate it using the R programming. Okay, you can generate the data visualization for publication ready. Okay, very smart figure you can create, you can create the dynamic figures by using the R software. Okay, also since it developed simple and effective programming language that includes conditional loops, conditional programming, loop programming, user friendly recursive functions. Okay, input and output facilities, so many functions, functionalities are there into this particular software that actually contribute just to have a good power. Okay, along with that, R is providing you the latex like documentation format. Okay, so like for example, whenever we are writing a research paper, we are just following a latex based system and we are just typing over there, formula is there. Okay, so R is freely providing this kind of facilities using the latex like documentation package are there. Okay, you can utilize those package, you can create a publication ready document for your purpose. Okay, so these are the few packages of power of R programming. Okay, now coming to the introduction of packages. So along with the things what you have seen, okay, so these are the general things, okay, whatever the system already being provided to you, okay, these are the very basic things. But suppose if you wanted to perform a specific type of research, maybe in a drought areas, maybe in a what I can say rainfall areas, maybe natural hazard areas. Okay, so many types of things, so many analysis you need to perform. Okay, so many researchers since already being done this type of research, they have published their own packages. You can utilize their research. Okay, since this is a freely available and is a very high community, you can utilize those packages. Okay, you can just use this extra functionalities into your software, and based on the extra functionalities you can perform your research in a very easy way. Okay, so R has its own base functionalities. Okay, when you install your R system into your computer, it is coming up with their base functionalities. Along with that, you can integrate its functionality by installing the packages. Okay, some outsource functions. You will outsource some extra analysis. Okay, analysis function into your machine. Okay, and utilize you can utilize those particular functions for your purpose. Okay, so those packages is being created by some other persons like me, like you, like anyone who is doing the research. Okay, they will generate their packages and upload into the CRAN, and anyone can utilize it. So nowadays in the CRAN we have 21,000 of packages. Okay, so you maybe for your time spare time, please do a research, okay, into the packages part, that how many packages are there, okay, what the package means and what type of packages are available. Okay, so you will see huge list of packages are there. So like for example ggplot among them, okay, dplyr among them, ggvis is there, stringer is there, lubricate is there. So dplyr is basically used for just processing the data, or you can say tidying the data, or you can say data preparation activities you will do data in using the dplyr package. There's a one more package called as tidyr package, just for tidying the data. As you saw, the first step of data analysis is just tidying the data. Okay, so you can do this activity by using the tidy package. Preparation of the data you can do by using dplyr package. Data visualization you can do by using the ggplot2 package, ggvis package. For generating a result or interpretation, you can utilize the string R package. Just to manipulate the data, manipulate the date based systems, okay, you can use the lubricate packages. So these are the few basic packages I have kept over here. Okay, rest of the packages we will cover in our advanced programming sessions. Okay, over there I will tell you about different kinds of packages, their functionalities, how these packages will help you out into your research. Okay, now coming to the basic commands. Okay, so how you will install the packages. So there is a function which is called as install.packages. So install.packages is a function which actually help you out to just install the package. And once your package is being installed, so package installation is, it means that just having a book into the library. Okay, so if your book is in the library, then you need to attach it, you need to find the book self number, okay, so that you can go and access this particular book from that particular location. Okay, so now you need to apply the library. Okay, you need to apply a library function so that you can directly reach to your particular book and you can access it. So two basic commands we need to utilize for installing the packages. First is install.packages, second is library functions. Okay, these things, those two things we will cover in a much more details, maybe in after some sessions. Okay, so these are little bit advanced topic we will cover later of this module. Okay, now coming to the some file extension.
Please, can I ask a question on this?
Yeah, please.
The
Yeah,
packages.
yeah, please. Mm-hmm.
So with what you are saying, so it means that each analysis and the kind of package you are supposed to install, right?
Yeah, yeah, yeah. Means any analysis can use any number of packages. Okay, so because
So how will you know that?
yeah,
Okay, how will you know that?
yeah. So
I mean,
this is good question. I can say this very very nice question. So this
two factors.
yeah.
How will I know that? Oh, if I'm doing regression analysis, I should use this package.
Yeah, 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 for sure. Yeah, that's a very nice question. Okay, so it depends on the need. Okay, as I told, package installation, package things is up to your need. Okay, so like for example, if you wanted to do the regression analysis, maybe you can Google it that what are the different packages which is providing the regression based analysis. So definitely there will be a packages come like LM package, maybe Broom package is there. Okay, initially in base R we have so many functions. Okay, along with that we have like tidy models packages there, broom packages there. Okay, so these packages are providing you the regression analysis. Similarly, if you are doing any spatial analysis, okay, maybe temperature based analysis or maybe landslide prone area based analysis, okay, you will have some geological data analysis. Okay, so at that time you are having some geo based packages are there. You can google it and you will find the name, and you can install those packages over here by using this particular function install.packages. And maybe like broom, you need to specify broom over here and you will install the package. Now just to utilizing the functionality of the broom package, you need to attach the library. Okay, you will apply the library in bracket, you will write the broom, so that you can utilize the functions of this particular packages. Okay, now coming to answer your specific question that how you will get the things, you will definitely you need to do some research. Okay, you need to google it that which packages are there which will help me out to deal this particular situation. Like for the regression you will get so many packages. Okay, depend on the need, depend on the requirement, you will search it and you will get the package name, and based on these two steps you can install it. Okay, now when you create a R program, okay, when you are just start working into the R software, okay, so definitely there will be a different files will be created. Okay, this is the important part you need to remember. Okay, so what are the different files will be created? The first file is created which is called as code file. Okay, so code file means whatever the code you have written. Okay, so these code will be saved at some places. Okay, so all those codes will be stored by using .r extension. Okay, what it mean by extension? So like for example you are storing your file like ppt file, like excel file. Okay, so what it mean by ppt? If there is their extension is .pptx. Okay, that log .docx, .rtf, okay, .xml, .html. Okay, so different file extensions are there depending on their type. So our code file is being stored by using the extension .r. Okay, similarly data file will be stored using the .rda, and workspace will be stored by using .rdata, and history will be stored by using .rhistory. Okay, so these are the few basic file extensions, okay, which we will play around in our coming sessions. Okay, we'll store the code by using .r, we'll store the data using .rdata. Okay, suppose is creating the workspace by using .rdata. Okay, the history by using .rhistory. Okay, so those are the few file extensions you need to remember. Okay, just to do the R-based programming activities. Okay, so here are the references and citations what I have utilized into this particular slide to create it. Okay, so now I am about to complete today's sessions. Okay, so again I will again tell to you, maybe if any one of your friend or want to explore this R programming languages, let them know so that he will also join this particular group and get benefited from this particular course. Okay, now I am open for the questions. If anyone have any questions, maybe we can discuss now. Yeah, please ask a question.
All right. Thank you very much. That was a wonderful presentation. I believe with this piece, gradually we are all going to get used to the program. I would like to find out if you could make a list of the packages we might need so that we can install them. Then when we start with the practical ones, we already have them installed. Because sometimes where we are, some of us might not have the network to favor us. So if you could make a list of the packages so that we could install them before we start with the practicals. Thank you very much.
Yeah. So yeah, I can understand. So basically, in this particular course, means what the things we are targeting. So we will move very slowly. Firstly, we will touch upon the base functionalities what base R is providing to us. Okay. So once we all will be comfortable with base programming, if we able to understand about what is programming. Okay, so if everyone is comfortable with these things, then we will move ahead for the advanced level of programming, because package programming is little bit advanced level of programming. Okay, so before that we will establish our understanding up to the level that we will understand what exactly programming is and what are the different functionalities is provided by the R software. Okay, so once we will comfortable with this particular base functionalities, then only we will move ahead for the package based programming. So no need to worry. Okay, we will cover all those things in such a way that everything will be clear to everyone. Okay,
Thank you very much.
yeah. Any other question?